Hi everyone, I'm Aaron Curtis. I maintain the Solar System Treks Mosaic pipeline, and today I'm going to give you a quick demo of how you can use it to create mono or stereo mosaics on the moon. So the web interface for the Solar System Treks Mosaic pipeline. When you install SSTMP, you will install it onto your Kubernetes cluster, and it gives you some endpoints. And the two main ones are slash workflows, which is the Argo workflows engine, and the API and the web interface to that are both at slash workflows. And then our interface to it, which is slash moon, which accesses the same data and actually is calling it's listening to a stream of events from that API. So as you can see, I've already got a few mosaics in here that I've processed previously, and you can expand these to look at the individual NACs. That highlighting there, you'll see sometimes there's areas that are, my mouse is over multiple NACs, and in that case it'll highlight several of them, which is a useful feature for debugging if you want to remove or add more NACs. And so in order to start a new mosaic, I don't know why that's gotten all weird. To start a new mosaic, you use this drop down, and there's a stereo mosaic workflow which uses AIM stereo pipeline to do the reconstruction, and then it also downloads the altimeter data and aligns your point cloud to the altimeter data. But a simpler solution is to use a mono mosaic if you're just looking for an orthophoto mosaic, and that just purely is using ISIS and GDAL. So I made a test mode which will go a little faster so we don't have to wait because it will take hours normally to do one of these. Well, let's choose a fun spot. I think my connection's a little slow. All right, let's do that. So make a mosaic, say here. It gives you, so this will be from 65 to 66. I think that's east to west, and then 42 to 43 south to north. And as soon as you hit OK, you'll see a new line shows up here in the list of workflows in the Argo interface. And if you click on that, you get this node graph. Now each node in this graph is a Kubernetes pod, which represents a Docker, well, a container. In this case, I'm using Docker. And all of these nodes are using the same Docker image. So there's a Docker image that has everything you might need to make a mosaic. So it has some GIS components, it has GDAL, it has AIM stereo pipeline, it has USGS ISIS version 4, and they've all been set up carefully to work the versions to work well together. So as you see, our select NACs task just finished. You can look at the output of any of these nodes. The inputs and the outputs are all saved. And you can see the output is just a list of NACs, which then each becomes its own container. And we download that NAC, and then we convert it from PDS to ISIS. And then we will calibrate it, and then you'll see this node graph converge once we've completed all the individual NACs. We'll begin the mosaic process. You can also, there's also a Prometheus resource monitoring working in the background, so you can click on any of these nodes and see what kind of system resources it was taking. So if you run into system resource problems, you have all this recorded, and you can optimize your process using that information. So there's a color code here. The colors on the inside of the polygons represent which step was last attempted, and the boundary, the borders of the polygons tell you what state that is in. Oh, it's interesting there isn't one here for failed. I'll need to add that. That's an oversight. because it's very possible for one of these workflows to fail partially. So if one of these steps, one of these NACs has a problem with it and it won't calibrate, um, the workflows will actually continue and just leave that one out. And of course, this is all configurable. The workflows are defined in YAML. You can actually look at that for the whole workflow or for each step. So the step we're entering now is the MOS range, ISIS MOS range. So what this does is creates a .map file which specifies the aerial extent of the mosaic and its resolution, and the projection also that we'll use in this next step, cam to map, which is projecting the image from a camera space image to a geographically projected image, and they're all projected using the same exact resolution and aerial extent and projection, and that's determined in this MOS range step. The next step is the equalizer. So this is another ISIS program, and what it does is it looks at the overlaps between the NACs and simultaneously solves for the best possible brightness and contrast, effectively, sort of stretch for each NAC. So it just makes it look like they were all taken with the same lighting, essentially. After that, we use NoSeam to merge all of the NACs and fade the boundaries, and then we'll convert to a TIFF. And that's how the pipeline works.